So the next topic in class 11th is thermal properties. So heat topic, we divide heat topic into 4 parts. Okay, ma? And the first one is called thermal properties of matter. Then we study heat transfer. Then we study thermodynamics and we study kinetic theory of gases. Okay. So first of all, can you say what is meant by heat energy? Heat energy, heat means what? Heat is a form of energy, that's it. Clear, ma? So it is a form of energy. Okay. Just like how light is a form of energy, sound is a form of energy, heat is also a form of energy. And heat naturally it flows from, okay ma? It flows from higher temperature body to lower temperature body. Clear, ma? So this is a natural property of heat. So it always travels from which body to which body? Higher temperature body to lower temperature body naturally. But you can make heat energy to flow from a colder body to hotter body also. That is also possible. But for that one, you need to spend energy. Are you able to understand? So for example, natural example, if I take this body of 100 degrees Celsius, clear number, and if I place one more body beside this one, whose temperature is 10 degrees Celsius, then what is the direction of heat flow? Heat flows from 100 degree body to 0 degrees naturally. Okay, ma? And can I make that heat can be transferred from 10 degrees body to 100 degrees body? Clear, ma? Can I do this one? Is this possible? Can I transfer heat energy from 10 degrees body to 100 degrees body? Is it possible? This is also possible, but we have to spend energy. We have to spend energy. Are you able to understand? No? It means external work must be done. Example of this one, can you say? Example where heat is transferred from colder body to hotter body. Heating of water, that is you are passing energy from hotter body to colder body. No, stove is very hot. No, kavalante chai pettanడి. Okay, water is very cool. So heat flows from higher temperature body to lower temperature body. But give me an example where heat is transferred from lower temperature to higher temperature. 0 to 100 heat should be transferred. Any example? Refrigerator is an example. No? In refrigerator, what we do? We take out heat energy from inside the refrigerator and we give that heat energy to the surroundings. What is the temperature of refrigerator inside? Inside the refrigerator, what will be the temperature? Less than 0 or 0. Okay. And what is the temperature of the surroundings? It will be 30, 40, anything. So we are giving heat energy from lower body to higher body. So what refrigerator it will do? It naturally takes heat energy from inside of the refrigerator and that heat energy is given to the surroundings. It means where temperature is lesser? Temperature is lesser inside the refrigerator. Temperature is greater in the surroundings. But still we are taking heat energy from inside the refrigerator and continuously we are giving to the surroundings. Are you able to understand, ma? So this is called as reverse heat engine. Okay. And to do this thing, to travel heat energy from lower temperature to higher temperature, what we have to do? We have to spend some energy. So refrigerator, will it work without any power source, ma? Without power source it will not work. It means that we are supplying heat, we are supplying energy to make this thing to happen, to make heat energy travel from lower temperature to higher temperature. But in this condition you need not do any work. Heat naturally flows from hotter body to colder body. Understood, Nama? This is about heat. So in the olden days, people were thinking heat as some kind of fluid. They were thinking hotter bodies have some fluid and the name of the fluid they have kept it as heat. So that fluid was traveling from one body to another body. They were thinking like that. So actually it is not a fluid, it is just a form of energy, that's it. Clear? So next we study about temperature. Okay. How can we define temperature? It is defined as the degree of hotness or coldness of a body. Okay, ma? So the degree of hotness or coldness of a body is called as temperature. What is the meaning of this one? By this we identify whether a body is hotter or whether a body is cooler. That's all. Okay, ma? So by comparison, we can say whether a body is hotter or cooler. This is called as temperature. Okay. For example, we can do one experiment, ma, here. We can take some 2 beakers here. Okay, ma? 3 beakers I can take. So in which water is filled at different temperatures. Okay. So consider this is water at 80 degree Celsius. Okay, ma? And consider this is water at 20 degree Celsius. And consider this is water at 0 degree Celsius. Are you able to understand, ma? So we are taking 3 different waters now. Okay. Now what I do is, clear? I will place my hand in 80 degrees water for some time. I am placing my hand in 80 degrees water for some time. Immediately I transfer my hand to 20 degrees Celsius water. Are you able to understand? In this 80 degrees water, I place my hand. Are you able to understand? And that hand after 5 minutes, I will transfer to 20 degrees Celsius water. Now can you say, what will I feel? What will I feel? Will I feel that, will I feel hotter or will I feel cooler? Huh? I feel cooler, no? Why? Because if I have placed my hand in 80 degrees water for some time, then my hand temperature also will become 80. That's all, Rama? So if I transfer my hand from, if I place for 5 minutes, then my hand temperature also will become 80, no? Because temperature of water was 80. Now if I transfer my hand to 20 degrees water, then I will observe that this water is cooler. This is what I observe, no? So in which condition a person feels cooler? A person feels cooler when heat energy is leaving his body. Okay, ma? When heat energy is going away from your body, then the person gets the sensation of coolness. Are you able to understand? Now what I do is, after some time, I will place my hand in 20 degrees Celsius water for 5 minutes. In 0 degrees Celsius water. Okay. So I am placing my hand here, and from here after 5 minutes, I transfer my hand to 20 degrees water. Now can you say what will happen? I feel hotter. Why I feel hotter? Temperature of water was 0. So my hand temperature also will be 0. So if I transfer my hand to 20 degrees Celsius water, this water is at higher temperature, no? So immediately I feel that the water is very hot. Are you able to understand, ma? So this is the definition of temperature. So whether you are feeling hotter or whether you are feeling cooler. So it is always a relative comparison, ma. Okay. So what is the initial temperature of your hand? That also decides whether heat energy is entering into your system or heat energy is going out of your system. Okay, ma? So in which condition we feel cooler, ma? We feel cooler. Okay, ma? In which condition? If heat energy leaves our body. Okay, ma? When heat energy is leaving from our body, then we feel cooler. In winter season, we feel very cool, no? What is the reason? In winter season, we feel very cool. What is the reason? In winter season, our body temperature is nearly some 34, like that. But what is the temperature of the surroundings? It will be less than 20, 15, 10, like this. So heat energy is traveling from where to where? Heat energy is traveling from our body to atmosphere. So definitely we feel cooler. That is the meaning of. And in which condition we feel hotter? So here I can write and vice versa, no? Vice versa means what? Clear, ma? So we feel hotter if heat energy enters into our body. Clear, na, ma? In summer season we feel very hot, no? What is the reason? Our body temperature is some 34, but temperature of the atmosphere is some 42, 45, like that. So heat energy is entering into our body. Then we get a sensation of hotness. Are you able to understand, ma? So make a note of this one. So in these conditions we feel hotter and cooler. Okay. So next we discuss about scales of temperature. Okay, ma? So scales of temperature. What is meant by scales of temperature, ma? So what are the different methods in which we can measure temperature is called as scales of temperature. Okay. So first one we have to measure about Kelvin scale. Kelvin scale. What is meant by Kelvin scale? The least possible temperature. The least possible temperature minus 273.15 degrees Celsius in the universe is taken as is taken as, clear ma? The starting point of is taken as the starting point of Kelvin scale. Okay? Are you able to understand ma? So what is the least possible temperature in the universe? This is the least possible temperature. So less than this, temperatures doesn't exist. Are you able to understand ma? So by using gas laws, when we have drawn a graph, then we got this temperature. Are you able to understand? So in the universe, there is a limit for lower temperature ma. And what is that limit? Minus 273.15 degree Celsius in Celsius scale. Okay? Less than this, temperature does not exist. And this is the temperature where energy of total system will become zero. Okay? For example, if you take any matter, the atoms in the matter or molecules in the matter, always they will be vibrating along their mean position. For example, if you take the molecules of this pen, so molecules of this pen also, they will be vibrating about their mean position. Okay? And if I reduce the temperature of this pen, these vibrations will reduce. The amplitude of vibrations will reduce. And if I cool this pen to minus 273.15 degrees Celsius, then the vibrations of these molecules will permanently stop. Are you able to understand? So energy of total system will become zero at which temperature? At minus 273.15 degrees Celsius. And below this, there are no temperatures. Are you able to understand ma? So there is a lower limit of temperature, but there is no higher limit. Higher limit is not there. Okay? 2 lakhs degrees of Celsius, 10 lakhs of degrees of Celsius, 20 lakhs of degrees Celsius, this is present. At the surface of the sun, you will find some temperature. At the center of the sun, you will find different temperature. And what is the temperature of the sun you are finding at the center? Same temperature you will find on surface of another bigger star. Are you able to understand? So there is no higher temperature for higher limit for temperature, but definitely there is a lower limit. And that lower limit is taken as starting point for which scale ma? For Kelvin scale. Are you able to understand? So therefore what we write? Minus 273.15 degrees Celsius is taken as 0 Kelvin. Okay? So this least possible temperature in the universe, that is taken as 0 Kelvin. Understood no? And if I want to rise here plus 1 degree Celsius, then in Kelvin scale also I have to add plus 1 Kelvin. Understood no? Clear? Therefore what will be its value, can you say? Minus 273 plus 1? Minus 272.15 degrees Celsius will be equal to 0 plus 1 is 1 Kelvin. Are you able to understand? So what do you understand? What do you understand? The division of Celsius scale and division of Kelvin scale, they are same. Okay? So what is the divisions? Divisions means difference between 2 points. No? So what is the magnitude of division in Celsius scale? Same magnitude of division is present in Kelvin scale also. It means 1 degree Celsius change is equal to 1 degree Kelvin change also. Are you able to understand? Changes are same. Temperatures are not same. Are you able to understand? So minus 273 and 0. Magnitude wise they are not same, no? Temperatures are same. Okay? But a change in temperatures are definitely same. So this is one point which you should remember in the case of Celsius scale and Kelvin scale. Okay? So let us make a note of that point. So what we write? We write that. Okay? Delta C is equals to delta K. Can you say what is the meaning of this one? No? Change in temperature of Celsius is equal to change in temperature of Kelvin. Changes are same. So here if 10 degrees is changing, in Kelvin also 10 degrees will change. Okay? But magnitude of temperatures, they are not same. That is the numerical values, they are not same. For example, if you write, so therefore make a note of that point. What we write? The change in temperature of Celsius scale is equal to change in temperature of Kelvin scale. What is the reason? Because the magnitude of division is same in both scales. Okay, ma? Magnitude divisions are same, but starting points and ending points, they are not same. That's it. Are you able to understand? So therefore I will write minus 273.15 degrees Celsius is equals to 0 Kelvin. Okay, ma? Now to this temperature, if I add a plus 273.15 degrees Celsius, then in Kelvin scale also how much I have to add, ma? In Kelvin scale also same divisions I have to add, plus 273.15. Okay. Therefore, if you add both of them, what you will get? Here I will get minus 273 plus 273, 0 degrees Celsius I will get. And here I will get plus 273.15 Kelvin. Okay. Or if you write approximately, then you can write 273 Kelvin. Understood, Nama? So 0 degrees Celsius, you can also call it as 273 Kelvin also. Understood, Nama? And what is the length of division in Celsius scale? Same division we have in Kelvin scale also. Division wise they are same, but magnitude wise they are not same. So here it is 0, there it is 273. Understood, no? This one difference you should remember. Completed, no? So that is why in some calculations also what we do, see now, for example, you write energy of gas molecule, energy of ideal gas molecule, you can write 3 by 2 RT. This is how you write. Energy of any ideal gas molecule, you can write it as 3 by 2 RT. Okay. And here T means definitely you have to write in Kelvin scale. Okay, ma? What is meant by T here? Total temperature of the gas. That you must write in Kelvin. Because SI unit of measuring temperature is Kelvin only, it is not Celsius. Are you able to understand, ma? So here T means Kelvin scale. For example, if temperature is given as 27 degrees Celsius, then can you substitute here directly? No, you have to make it converted into Kelvin scale. How can I convert this one into Kelvin scale? So 27 plus, I have to add what? I have to add 273.15, or just you can write 273. So 27 plus 273, it will become 300 Kelvin. Then this 300 Kelvin you can substitute here. Are you able to understand? And similarly, for example, if you want to calculate a change in energy of ideal gas molecule, then it is 3 by 2 or delta T. This is how I have to write. Okay, ma? If I heat a gas, its temperature rises, no? Then temperature also will, energy also will change. So change in energy can be written as 3 by 2 or delta T. Delta T means what? Change in temperature. Okay. So in the data he gave that change in temperature of Celsius scale is 10 degrees Celsius. Okay. Now can I write this one directly here? This one I can write directly. Why? That's what we have studied now here. Changes are same. Change in Celsius and change in Kelvin, they are same. Why? Because length of each division is same in Celsius as well as Kelvin. So ఒక డివిజన్ మారితే ఎంత టెంపరేచర్ మారుతుందో సెల్సియస్లో, ఒక డివిజన్ పెరిగితే కెల్విన్లో కూడా అంతే మారుతుంది. Are you able to understand? So change in temperatures are same. So here you can write delta T is also equal to 10 degrees Celsius. So definitely you can substitute. So are you able to understand my difference between Celsius and Kelvin? That's it. Make a note. Okay. Next we study about Celsius scale. Okay. So in Celsius scale there are certain limits. Limits means what? What is the lower fixed point and higher fixed point? We have certain limits to this one. So in this scale, the freezing point of water, okay, is taken as 0 degrees Celsius. Okay. So water freezes at a particular temperature. No? That temperature is taken as a starting point for Celsius scale. It doesn't mean that negative temperatures are not there. Negative temperatures also are present. Okay. So 0 degree Celsius. So this is the starting point for Celsius scale. And which is the higher limit? This also you can call it as lower fixed point also. LFP, lower fixed point. Understood, Nama? And the boiling point of water. What is meant by boiling point, ma? The temperature at which water converts into steam. That is called as boiling point. No? That boiling point of water is taken as what? Is taken as 100 degree Celsius. This you can call it as higher fixed point. Okay. So in between lower fixed point and higher fixed point, how many divisions are present? 100 divisions are present. Are you able to understand? So therefore, between LFP and HFP, 100 divisions are present. 100 divisions are present. Okay. Similarly, if you write the same temperatures in Kelvin scale, 0 degrees Kelvin, I can write it as 273 Kelvin, no ma? And 100 degrees Celsius, you can write it as 373 Kelvin. So here also, how many divisions we have? So here also we have 100 divisions. Clear, no? In Kelvin scale also 100 divisions only, between 0 and 100. It means 1 degree change in Kelvin is equal to 1 degree change in Celsius. That's what we have been discussing, no? Clear, no? Therefore, what we write? Therefore, in both Celsius and Kelvin, 100 divisions are present. 100 divisions are present between freezing point and boiling point. Freezing point and boiling point. Okay, ma? There are 100 divisions. So because there are 100 divisions, one division in Celsius is equal to one division in Kelvin. Already we discussed, no? Again we are writing. Okay. Clear, no? So the starting point of Celsius is taken as which temperature? It is taken as that temperature where water converts into ice, which is called as freezing point. That is taken as 0. But in Kelvin scale, which one is taken as 0? Lowest possible temperature is taken as 0 in Kelvin scale. Understood, no? And here, which is the higher fixed point which is taken in Celsius scale? That temperature where water converts into steam. That temperature is taken as 100. Understood, no? So that is the difference. Clear, no? So then we write another scale which is called as Fahrenheit scale. Fahrenheit scale. Okay. So freezing point of water is taken as 32 degree Fahrenheit and boiling point is taken as 212 degree Fahrenheit. Understood, number? So in Fahrenheit scale, what are the limits you are taking? Lower fixed point is taken as 32. What is meant by lower fixed point? Temperature where water freezes into ice or where ice starts melting, both are same. So that temperature is called as 32 in Fahrenheit scale. And the temperature at which water boils, that temperature is taken as 212 degree Fahrenheit. So in between 32 and 212, how many divisions are there, ma? In between both of them, how many divisions are there? 212 minus 32, 180 divisions are present. 180 divisions are present. Understood, no? Between 32 and 212, how many divisions? 180 divisions are present. Okay. But in a Celsius scale, how many divisions are there? 100. 100 divisions are present. But the change of temperature is same, no? So 212 minus 32, what is the change in temperature? 100 minus 0 also, same change in temperature. Because this is also freezing point, 0 degrees is also freezing point, 0 degrees Celsius is also freezing point. 212 degree Fahrenheit is boiling point and 100 degrees Celsius is also boiling point. Therefore, what I can write, therefore, 180 divisions in Fahrenheit scale is equal to 100 divisions in which scale? 100 divisions in Celsius scale. Follow avutunnaru careful ga? Clear, ma? So in Celsius scale, between freezing point and boiling point, we have 100 divisions because their lower temperatures were 0, higher temperature was 100. But in Celsius, it is 32 and 212, no? Same temperatures. Freezing point 32, boiling point 212. So how many divisions? 180. So 180 divisions, what is the change in temperature? Same 100 divisions will represent in Celsius scale, no? So 180 divisions in Fahrenheit scale is nothing but 100 divisions in Celsius scale. Therefore, 1 division in Celsius will be how much? 1 division in Celsius will be how much? Can you say? 100 is there, no? 100 into 100 can be written as 100 into 1, no ma? 100 into 1 division. So take this 100 to this side. Therefore, 180 divided by 100 divisions in Fahrenheit scale. Can I write like this? Arthamutunda? 180 is equal to 100. If I want 1 division in Celsius scale, send this 100 to other side. Here already 180 is there, no? 180 by 100, 1.8. Clear, no? Therefore, 1 division in Celsius is equal to 1.8 divisions in Fahrenheit. Are you able to understand now what is happening? And how many divisions in Kelvin? In Kelvin? One division only. But in Kelvin it is equal to 1 division in Kelvin. Are you able to understand? That's what we studied, no? 1 division in Celsius and 1 division in Kelvin, both are same. But 1 division in Celsius is equal to how many divisions in Fahrenheit? 1.8 divisions in Fahrenheit. Is it clear? So I will give you a small question, try to answer. Okay. So if temperature of a body is raised by 10 degree Celsius, clear ma? Then how many degrees should be risen in first one? Kelvin scale, Fahrenheit scale. Can you answer this question? We are taking a body, and the temperature of body is raised by how many degrees? It is raised by 10 degree in which scale? Celsius scale. Understood, no? Then if I want to raise the same amount of temperature in Kelvin scale, here how many degrees I have to change? 10 degrees only I have to change. Why? Because one division in Celsius is nothing but 1 division in Kelvin. So here if temperature is 10, in Kelvin also 10 degrees only I have to rise. But in Fahrenheit, 18 degrees I have to rise. Why I have to rise 18 degrees? Because here 1 division is equal to 1.8. What is the total rise in temperature? 10. 10 into 1.8 is 18 degrees should be risen. Understood, Nama? So make it out. So therefore what we write? Okay, ma? Therefore we write, okay, in Kelvin scale, temperature should be risen by how many degrees? 10 Kelvin. Okay, ma? But in Fahrenheit, temperature should rise by 10 into 1.8. So 18 degree Fahrenheit. That's it. Okay, because each division in Celsius is equal to 1.8 divisions in Fahrenheit. Understood, no? So division in Celsius is bigger, ma. Division in Fahrenheit is smaller. Okay, how many times bigger? 1.8 times bigger. Which one? Each division in Celsius scale. So therefore 10 degrees Celsius if I want to rise in Fahrenheit scale, 10 degrees Celsius if I have to write, then in Fahrenheit scale I have to rise totally 18 degree Fahrenheit. Then only same amount of rise in temperature will happen. Clear, no? Then we study the fourth scale, which is called as Reamer scale. So generally it will not be asked in the examinations, but very rarely questions will be given on Reamer scale. Okay, so in Reamer scale, freezing point of water, freezing point means lower fixed point, is taken as 0 R, 0 degrees R, 0 Reamer. And boiling point of water, everything we are taking water only, ma, be careful about that. Boiling point of water, which is called as higher fixed point, is taken as 80 R. Okay, so in Celsius we are taking 0 and 100, no, ma? But in Reamer scale we are taking 0 and 80. So therefore how many divisions are there here? 80 divisions are present. Okay, ma? 80 divisions. Okay, So therefore 80 divisions in Reamer is equal to 100 divisions in Celsius, no? And it is equal to 180 divisions in Fahrenheit. Are you able to understand, ma? Therefore what we write? Therefore 80 divisions in Reamer is equal to 100 divisions in Celsius, and it is again equal to 180 divisions in Fahrenheit. Understood, no? So this information you should always remember, because in conversion of scales, if he gives the question on change in temperature in different scales, then by using this one you can calculate. Understood, no? And it is equal to 100 divisions in Kelvin also. 100 divisions in Kelvin scale also, because the magnitude of division in Celsius and Kelvin, they are same. Understood, no? Therefore what I write? 1 division in Reamer. 1 division in Reamer is equal to how many divisions in Fahrenheit? 180 by 80 divisions in Fahrenheit. So like this you go on calculating any number of calculations. Okay? So 80 by 80 is how much, ma? So 2 9s are 2 4s are 9 by 4 divisions in Fahrenheit. Okay? Similarly you can calculate for Reamer and Celsius. No? You can calculate for Reamer and Kelvin. Like this you can do any number of calculations. Understood, Nama? So therefore if 10 degrees should be risen in Reamer, then how many degrees should be risen in Fahrenheit? 9 by 4 into 10. 90 by 4. 45 by 2. 22.5 degrees should be risen in Fahrenheit scale. Are you able to understand? Like this. Like this you can go on doing any number of calculations. So you have to remember lower fixed points and higher fixed points of all the scales. Then you can convert the change in temperature in any scale to any scale. So this is the conclusion of total information which we have studied until now. Understood, no? 80 divisions in Reamer is equal to 100 divisions in Celsius, is equal to 180 divisions in Fahrenheit, is equal to 100 divisions in Kelvin. Okay? Now, conversion of scales. How can I convert one scale into another scale? Okay? So, conversion of scales. So there is one formula to calculate conversion of these scales. Now if you remember this one, you can convert any scale into any scale. Okay? I am not discussing about change in temperatures. I am discussing about converting temperatures itself. Okay? So how I can write? I can write C minus lower fixed point divided by HFP minus LFP is equals to K minus LFP divided by HFP minus LFP. Okay, ma? So this is equals to R minus 0, R minus LFP divided by HFP minus LFP. Okay, ma? So this is equals to F minus LFP divided by HFP minus LFP. This is the formula which I have to use. Okay, ma? Not only these 4 scales, ma, any scale you can write in this format. Understood? No? You can equate all of them. Okay, now listen. C means Celsius, no? What is the lower fixed point in Celsius? 0. Higher fixed point? 100. Lower fixed point? 0. Kelvin, lower fixed point? 273. Higher fixed point? 373. Lower fixed point? 273. Reamer, lower fixed point? 0. Higher fixed point? 80. Lower fixed point? 0. Fahrenheit, lower fixed point? 32. Higher fixed point? 212. Lower fixed point? 30. That's it. Understood? No? So not only these 4 scales, if he gives any scale, okay, so sometimes he will give some hypothetical scales. It means he will fix some lower fixed point and higher fixed point. According to that, you have to do the calculation. Whatever it may be, this formula will be always useful. Are you able to understand? You can write any scale. Not only this scale, any scale you can write down. If you want to invent another scale, then also you can write in the same format. Understood, Nama? Now let us simplify this one. So C by 100 is equals to K minus 273 divided by 100 is equals to R by 80 is equals to F minus 32 divided by 180. You can write like this. If you want to further simplify, so 0, 0, 0, 0 you can get cancelled, and everything you can divide by 2 also. So 5, 5, 4, 9. Therefore, how can you write? So C by 5 is equals to K minus 273 by 5 is equals to R by 4 is equals to F minus 32. F minus 32 divided by 9. You can write like this. Now by using this one, you can compare any two temperatures. Okay, if I want to compare these two, just you take C by 5 is equals to F minus 32 by 9. If I want to compare these two, so just take these two quantities like this. Understood, Nama? You can compare any temperature in any scale with any other scale. Okay, so you need not remember this one also. I just remember this relation, this one, or you remember this one. Okay, then you can convert any scale into any other scale. Okay, so I will write a small question, so try to answer it. Question is like this. So find a temperature where it has same magnitude in both Celsius and Fahrenheit. This is the question. Okay, ma? So you find out that temperature which shows the same reading. Magnitude is same means what? Here magnitude means that I am trying to say same reading. Magnitude, we should not write same reading in both Celsius as well as Fahrenheit. Are you able to understand? And magnitude is also, I think, correct only. You do one thing, same reading and same magnitude. That is better. Okay, magnitude is also same, reading also will be same. What is the temperature? Can you say? Celsius and Fahrenheit? Minus 40 is correct. Okay, ma? So how did you do that? Sima, he is asking comparison between which two scales? Celsius and Fahrenheit, no? What is the relation between Celsius and Fahrenheit? C by 5 is equals to F minus 32 by 9. That is what you have to take, no? So take them. So C by 5 is equal to F minus 32 divided by 9. This is what you have to take. So what he is saying, reading also should be same, magnitude also should be same. It means same temperature. Same temperature will have same reading in both scales. Okay, so what is the meaning of this one? It means that C is equal to F is equal to X. Can I write like this? C means temperature in Celsius. F means temperature in Fahrenheit. And both of them, they are equal, he is saying, no? So instead of both of them, can I write X here? I can write X. So substitute. So X by 5 is equals to X minus 32 divided by 9. Okay, ma? Do this calculation. So 9X is equals to 5X minus 160. Okay, so 4X is equal to minus 160. So X is equal to minus 40. So what is meant by X is equal to minus 40? Okay, ma? So I can say that minus 40 degrees Celsius and minus 40 degree Fahrenheit both are same. Okay, so magnitude wise also they are same. And reading also will be same only. Same reading. So for example, if you take 10 degrees Celsius in Celsius, so that will have a different reading in Fahrenheit. In Celsius you will have one reading, Fahrenheit you will have another reading. Understood? For example, what is the temperature of human body? You say 34 degrees Celsius. But in Fahrenheit it's somewhere something around 98 degree Fahrenheit. So readings are not same. But there is one temperature where reading is also same, temperature is also same. And what is that one? That is minus 40. Okay, at minus 40 degrees Celsius, Celsius scale also will read minus 40, Fahrenheit scale also will show minus 40 only. Understood, no? So this is the technology, this is the equation which we can use to compare temperatures of any two scales. Okay, I will write one more question, so try to answer it. Completed, ma? Huh? So next question is like this. Break altara. Enta type? Go for break. Okay. Sima. So faulty thermometer shows freezing point as 5 degrees Celsius. Freezing point means lower fixed point. No? So actually it should be 0, but this is a faulty thermometer. No? So it is showing wrong readings. Readings are shown wrongly here. So to this faulty thermometer, lower fixed point is taken as 0 degrees Celsius, and higher fixed point is how much? Higher fixed point is 90 degrees Celsius. Okay, ma? So even though it is a faulty thermometer, this thermometer also you can take it as new scale of reading, no ma? This thermometer you can take it as new scale of reading. Are you able to understand? So therefore, how to compare? Then what will be the reading for 30 degrees Celsius? So in Celsius scale, temperature is 30. That 30 will be shown as which temperature in this faulty thermometer? Are you able to understand? It means a comparison is between in which two scales? Comparison is between faulty scale and Celsius scale. 30 degrees reading will be shown as which reading in faulty scale? Understood, no? 40 also it is Celsius scale only. This faulty thermometer, it is Celsius scale only. But it is faulty. Faulty means what? It is showing wrong readings. Are you able to understand? So this faulty thermometer also I can take it as new scale of measurement. That's what we said, no? Any scale, always you can write in the same format. So even faulty thermometer also, you can take it as a new scale of reading. Okay? So what is the data I have to write? So X minus LFP divided by HFP minus LFP is equals to, I have to compare Celsius temperature number. So C minus LFP divided by HFP minus LFP. So this is what I have to do. Okay. Now can't you substitute and get the answer? Come on. Okay, ma? So anybody got the answer? So X minus, what is the lower fixed point of faulty thermometer? 5. Higher fixed point is 90, lower fixed point is 5. And which temperature I have to measure in this faulty thermometer, ma? 30. So 30 minus, what is the lower fixed point of Celsius? 0. Higher fixed point is 100. Lower fixed point is again 0. That's all, no? So this is the method which we have to adopt here. So X minus 5 divided by 85 is equals to 30 divided by 100. Or 3 by 10 you can call it. Okay. So therefore, do the calculation. So X minus 5 by 85 is equal to 3 by 10, no? So you can divide by 5, no? 5 2s are, this is 5, 10s are 7s are, 17s are. Clear, no? So therefore, 2x minus 10 is equals to 17 3s are 51, na? 51. So 2x is equals to 61. So x is equals to 61 divided by 2. How much, ma? 30.5 degree. Okay. So this is the reading shown by faulty thermometer for which temperature? For a temperature of 30 degrees. Okay. So actually it should show a reading of 30. But because this is a faulty thermometer, it is showing how much reading? It is showing 30.5. So have you understood what is the method we have used, ma? So even faulty thermometer also we are taking as a new scale of reading. Okay. And we are doing the calculation. So make a note of that point. So even faulty thermometer is taken as new scale of reading. Okay. And we are doing the calculation. 30 you got, huh? No. అది చేయకుండా ఇది